Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this third lecture of Module 3 on physico-mechanical attributes of geoground and geomaterial. In previous lectures we have discussed about some physical properties of rocks which are going to influence the engineering property or mechanical properties of rocks. Thus, in these lectures we will elaborate different types of strength related engineering property or mechanical property of rock, which are very important for engineering geological applications. Friends, in these lectures we are going to elaborate about engineering properties of rocks. In these lectures we are going to cover about need of engineering properties of rocks and parameters used, then methods for determination of engineering properties of rocks, and then significance in brief. Friends, as you know, the rocks are basic elements of rock strata or ground. When we are going to utilize rock for engineering purposes, then it is important to determine engineering properties of rocks. For discussing these things, we have to concentrate on these three questions: why, what, and how. In this way, we are going to elaborate our concept today. Why we require engineering properties of rocks? What are the properties we are going to determine, and how we are going to determine? As far as need is concerned, the engineering properties of rocks are required because it is utilized in selection and preparation of rock material for construction purpose. It is important for evaluation of the geological hazards and mitigation by applying engineering solutions, and selection and characterization of rocks strata by knowing the engineering properties of rocks. In all these three views, we are going to categorize rocks in view of their responses with respect to external forces due to development of engineering project or construction of some engineering project, civil engineering project, excavation related project concerned to mining engineering, or recovery related project related to petroleum engineering, etc. Therefore, we required engineering properties of rocks as important component of our physico-mechanical attributes of geoground or geomaterial. Friends, in these lectures we are going to discuss about the need and others. We have already discussed, and What we are going to estimate in case of rocks, friends, we have already discussed. If you see this point here, this is a purely rock material. This is the rock strata traversed by number of discontinuities or joints and others, but this intact part is playing a major role in the development of this ground and providing the major supporting elements of this ground or strata. Therefore, we require to determine first important parameter is strength. Strength, we have different type of strength based on environment of stress. If compressive, then compression. If tensile, then tension. If the shear, tangential, then shear. Based on composition also, we are going to see this comprehensive and tensile. These two are counterpart of each other. The shear is slightly different than this. Here only the way of presentation, strength response with respect to different directional change in stress or load or force. Based on condition, it is under uniaxial condition or it is under triaxial condition. And then important mechanical property, we have modulus, modulus of elasticity, modulus of rigidity, bulk modulus, and another parameter, Poisson's ratio, which we have already discussed in our previous discussion during the development of the fundamental platform. Next question is how we are going to estimate. Some of the basic, you can see what is the fracture, and the fracture is a formation. Before discussing how we are going to determine, here we are going to learn about some basic aspect. Although you know in our previous discussion, fracture is a formation of plane of separation in rocks, and this plane of separation finally forming the rock in form of rock strata or rock stratum. Brittle fracture. Brittle fracture is the process by which the sudden loss of strength occurs across a plane following little or no permanent deformation. And ductile fractures, here the process, it is the gradual process where the permanent deformation without losing stress carrying capacity, we are going to define as a tensile failure. And as far as this concept of strength is concerned, it is a maximum stress attained before failure. So value of maximum stress attained before failure is recognized as strength. Residual is means remaining, and this beyond peak strength, the rock may still have some strength as a remnant, and this minimum or residual minimum stress bearing capacity of rock, or in another words we can say that residual strength of the rock. Here I try to show, before discussing this, I try to show if we are going to plot this stress strain curve, stress and strain, then we are going to get this type of curve. This linear portion, here we have already discussed in our certain forum. This portion we are going to recognize as elastic region, and here this curve is started deviating. This is the yield point and this is the peak point. After this, we are recognizing as the sample, rock samples under compression is going to lose strength, and if it is a brittle failure, then this curve is going to sudden fall. It's like this. And if semi, then it slightly survive for then fall, and if ductile, then it have constant value or considerable value of stress before ultimate failure for the longer strain development. This type of behavior generally we observe in rocks at high temperature and pressure condition, combination of temperature and pressure condition in geological or experimental points of view. This peak value, as per definition, the value of this stress before failure is recognized as stress. If the system is a compression, then the compressive strength. If the system is a tension, then it is tensile strength. Now we are going to see how we are going to determine strength. We have two types of approach. One is a direct approach and another is indirect approach that we are going to recognize in terms of indices or index. In direct approach, we have uniaxial compressive strength or uniaxial tensile strength, then direct shear strength, then the triaxial compression induced shear strength. In uniaxial compression, here quickly we are going to summarize. Generally, we are utilizing a cylindrical sample cored from collected rock. In this, we have one consideration about this diameter d and length. Generally, we are utilizing this diameter as 54 mm, that is recognized as annex size. We have different sizes. Time to time we will discuss annex size, BX size, EX size, etc. Here, as per International Society of Rock Mechanics recommendation, we are considering this ratio of height means length, this L by D, length to diameter ratio as 2.5 to 3, not beyond 3. This value we have developed on the basis of number of experiments on varieties of rocks having different L, different D. Simply this type of cylindrical sample in simple way, we are going to compress by putting load here. You can see this is the material testing system where we are going to put a sample, and there is some arrangement of dial gauges to measure the strain, another to axial, to lateral. Simply through oil push, this platen starts moving up, which are going to apply load on this, and at a particular value of the load, this samples start showing development of discontinuities, and this stage we are going to recognize as failure. For such type of testing, we have some simple specification about importance. Shape and size, it is cylindrical, and diameter not less than an x size. This is the standard size, 54 mm diameter. Then the height to diameter ratio or length to diameter ratio is 2.5 to 3.0, and the tolerance on dimensions of samples, we have some smoothing surfaces, and this end of the sample flat up to order of 0.02. Then we have some other specification. Here important thing is a rate of loading per minute or per second depending on the condition, and environmental condition with natural water means natural samples we require to calculate. Here calculation is a very simple. Applied load, if applied load is a P, then divided by the area cylindrical sample, so you can easily determine the area of this type of cross section. If you know the D is a 54, then you divide by 2 and take the pi r square concept, and you can determine easily the strength. Generally strength we are recognizing traditionally sigma c. So sigma c is equal to P by A. Here P is a force, then the stress is also a vector or higher order vector. Next, if we have same system which are going to pull this sample, then the system become under tensile stress and strength. By using same formula, we can say that it is a tensile strength. Tensile strength, same condition. If in place of compression, if we are going to pull this cylindrical sample, then we again going to get this type of curve between this stress and strain. This peak value we are recognizing as the tensile strength. However, it is very difficult to attach this zone through machines by using gear or using some hook and others. The distribution of stresses in the sample is uneven and errorful. Sometimes may cause failure at this point, sometimes cause failure of the hook point, sometimes failure near the gear point. So therefore, to determine the tensile strength of rock by pulling concept or the true tensile stress environment, it is very difficult, because this type of system going to provide some errorful result. After lot of discussions and others among the researchers, then we have followed one indirect method recognized as indirect Brazilian test. After Brazilian, this is the Brazilian case. So first we are going to see tensile strength of rock is among the most important parameters because it's going to influence rock deformability, rock crushing and blasting results. Directly it is very difficult to determine and errorful also. Therefore, we have followed the Brazilian test. In Brazilian test, we are going to utilize disc shaped sample. You can see this type of disc shaped sample, and these disc shaped samples we are going to load under some loading system. Here you can see this loading system. We have one notch here. We are going to pressurize this, and this going to direct some stress. So this sample, this sample is under compression. Here these two contact point is a crushed in nature and experience shear stress. However, this middle point is under tension, although we are going to put the compression, but due to induced effect, this come under tension and ultimately split. So this tensile strength by Brazilian test we can easily determine. Simple, this P is representing the load, 2 times load divided by pi, diameter of sample and the length of sample. In this case, the length should not be more than 1. It should always less than 1. So in this way we can put the value of this load at which the sample is started splitting, and then pi 22 by 7 or 3 point whatever value you can put, and then you can utilize D or R and then L, and you can easily calculate this. This type of system we are recognizing Brazilian case, and in this system we are going to easily determine tensile strength with minimum error. But this is indirect method. Another we have, if you see, and we have discussed also, we have 3 types of stress condition: maximum stress, intermediate stress and minimum stress, or minimum stress here, maximum stress here, intermediate. So in uniaxial conditions we have sigma 1 is equal to sigma 3 is equal to sigma 2 is equal to sigma 1, means uniaxial. But in case of triaxial, we have 3 stress condition, and true triaxial we have some limited machines and required cubical sample for easy handling. Here we are having one chamber here. I have taken this figure. This chamber is going to contain this rock sample and this rubber membranes and other. Then whole system we are going to put under confinement by using oil. And the upper part we are going to apply normal load. This is stationary, but due to this piston oriented, this platen started moving, and here the sideways we are going to confine this sample. If we are going to see this system, when we are going to increase confinement, suppose confinement we are using sigma 3 1 dash, sigma 3 double dash, sigma 3 triple dash, where sigma 3 triple dash is greater than sigma 3 double dash, which is greater than, means this minimum. Then deviatoric stress, if the confinement is less than deviatoric stress, or indirectly strength is less under close to uniaxial. But when confinement is more, then there is increment in strength. For determination of the shear stress, we are going to utilize here difference delta sigma. This delta sigma is nothing, it is simply sigma 1 minus sigma 3, and here this sigma 1 and sigma 3. In this way, taking the diameter of this, we are going to take in this way by changing different sigma 1, sigma 3, and we are going to draw the line. When we are going to draw tangent, then we have two components. One component is crossing here as on the shear stress. This is recognized as C, and we are going to recognize cohesive strength. And this, if we are going to draw this angle theta or phi, this phi is angle of internal friction. We have one good relationship proposed by Mohr-Coulomb in very early. Shear strength is equal to cohesive strength plus normal stress, and for normal tan phi. Phi is angle of internal friction, sigma n is a normal stress, and C is cohesive stress. These two components responsible for the shear stress of the. In this way, we are able to calculate the value of tau, and in triaxial condition, indirectly, we are going to determine shear strength. These are some major attempts for direct measurement of the strength under compression, under tension, under shear. Beside this, we have directed similar to this tensile, we have direct shear. In this, we are going to put samples and going to provide the tangential, or we are going to make some system where we are going to put this have cut, so going to provide some direct shear stress condition. Beside this, we have some indirect method among like point load strength index, like slack durability index, like P wave and S wave velocity based index, like Smith rebound hardness based index, like protodiagonal index. In this, we are going to discuss some important we are utilizing till date. So one of the important indirect method is a point load index test, very simple and very useful. Point load test as indication of the compressive strength, strength of irregular rocks or core samples, or this any type of materials or rock we can utilize for this purpose. It may be cubical, it may be rectangular, it may be cylindrical, diametrical or axial. Simply we are going to calculate IS is the point load strength. It is a simply load applied to break the samples divided by distance between two pointers. Here I can show you. You can see the distance D between 2 points by pressurizing this through oil pumps. At a certain distance, it starts at the certain reading, certain load values start following, failing. If the load is a P and the distance between these 2 points is a D, then P by D square is equal to point load strength index. This relationship requires some corrections factors and others for estimation concerned to the strength of rock in very simple way. This instrument is a very simple, economical and easy for use in field as well as in laboratory. Next important is a rebound hammer, very handy. This rebound hammer is a handy instrument consisting of a spring-loaded steel hammer. It is used to measure indirectly value of uniaxial compressive value for determination of uniaxial compressive strength of rock. You can see this is very simple. It may be 500 gram. Here you can see very simple working rebound system. Here we have a spring. This is the central rod connected with this, and here we have hung some mass. This here we have a scale and one spring here also. Then this tubular type body here. When we are going to put this, when the plunger is at this point, when we are going to put this plunger, when the plunger housing with this hammer is firmly compressed against the rock surface or rock strata or any concrete or anything, the spring loaded hammer gets released automatically and rebound after giving an impact of energy. The exact amount can be read out from the scale given on in the graph card of the rebound hammer. This concept I have taken from this book Engineering Geology, written by Gangopadhyay. Yes. Usually an energy impact of 0.075 mkg is satisfactory, and the rebound of the hammer is related to compressive strength. Therefore, at elementary levels we are going to utilize this Smith hammer frequently in field as well as in laboratory also. The rebound distance of the hammer with respect to plunger is measured from the scale attached to the frame of hammer. And in this way, for example, you can see here the rebound number denoted by R. R is equal to 49, R is equal to 61, R is equal to 65. In standard test, this generally represents, so you can see the 633 kg per cm square strength, another 61 is representing about the 857 kg per cm square, and the 65 is representing the 935 kg per cm square as a strength. So indirectly, without going any complication, we are going to determine this value of strength very easily. So on the basis of UCS data determined based on the destructive or direct test, varieties of rocks and number of samples and others, so we have categorized the strength in 6 categories starting from very low to very high. Here you can see this rock showing value less than 5 MPa categorized as very low, 5 to 25 MPa as a low, 25 to 50 moderate, then 50 to 100 medium, then 100 to 250 high, and then more than 250 MPa very high. So in this way we are going to categorize this. Other aspect related to modulus and others we will discuss time to time as per our requirement. This is particularly we are going to discuss about this strength related concept. This concept was prepared based on the book of Introduction to Rock Mechanics written by this Bhutkuri and the Kyatsumama, and this Gangopadhyay. This some portions I have taken from this book, Engineering Geology, particularly the Schmidt-Hammer test, and then well in general, and then these two books. As far as conclusion is concerned, friends, as you know, the rock is a principal element of the rock strata and rock material. Therefore, it is necessary to know the engineering properties of rocks. This is the engineering property of rocks are required for development of engineering project and engineering geological application. Engineering properties of rocks are related to strength response of rocks. So we can say that mechanical property or physico-mechanical properties also. These properties are determined using direct and indirect method, and we have discussed. And on the basis of compressive strength value, the rocks can be categorized in 6 categories starting from very low to very high category of strength. Dear friends, in this class we have discussed about engineering properties of rocks, which are also known as mechanical properties of rocks. And friends, we know that the rock strata are geomaterial, is principally composed of rocks and some discontinuities. So rocks are major supporting component. Therefore, it is very important to know about engineering properties of rocks, and we have elaborated particularly related to strength concept, how to determine strength under different categories and different stress condition and environment. Thank you.